Good day, everyone. I'm Richard Martel with Galdos Systems, and I'm going to provide a brief overview of the work done in the compliance area with respect to validating GML geometry representations. There were two main deliverables. The validator itself is the software component, and this took the form of extensions to the existing GML validator. And we also prepared a companion engineering report that provides some technical details. If anyone's interested in those, please feel free to consult that document. Now, the test requirements were extracted from several documents, and these were the three main ones, starting with the GML AIXM profile itself, which makes use of, or is based on, the GML standard. Now, many of you appreciate that GML itself makes use of quite a range of geomatic standards defined in the ISO 19100 series. The most important of which for this exercise was the spatial schema, and in fact this was the source of most of the geometry constraints. Now, there are two things to appreciate here. Firstly, the profile prime directive, thou shalt not contravene any base standard. And secondly, that the assertions or the constraints flow upward from the reference standards. So very often, the main document is in fact just the tip of the iceberg. Now, many of you will appreciate that the GML geometry model does cover a lot of ground. Now, the AIXM profile prunes the model and discards geometry elements that are considered to be non-essential in the aviation domain. So the ones that remain are listed here, and you'll note that in fact the AIXM profile does define new geometry elements that extend some of the fundamental GML types. These are identified here with the AIXM prefix. So this is done for both the point, curve, and surface geometries. And the profile also restricts allowable curve segments and surface patches, as noted here. Now, this is a sample of some of the geometry constraints that were implemented in the validator. I'll elaborate a little bit on the last one, verifying that the surface boundary is correctly oriented. Now, there are a couple of rules here, namely that the exterior curve, or the exterior boundary of the surface, is oriented in a counterclockwise manner, and the interior curves are oriented clockwise when viewed from above. This is with respect to the upward normal. So in essence, what this means is that the interior of the surface is located to the left of a boundary curve. Now, there are actually a few ways available to execute the test suite. There are links here in the document, so feel free to follow these to obtain some of the further details and learn more about how to actually execute the test suite. Now, the official OGC test harness is Team Engine, now at version 4. So the test suite is running in that now, and this is available at the OGC beta testing facility. It's also possible to run the test suite in the Eclipse integrated development environment, and very often reference implementers and test developers will use this. And the latest test suite releases are also made available by the OGC, as noted here. Now, there are a couple of benefits worth noting here, and the most important being that the test suite is schema aware in the sense that it is not tied to any particular application domain. That is, you can run the validator against any GML data representation, regardless of the application schema it uses. It will basically identify geometry elements that are defined in the application schema and verify that they are correct. So as noted here in the AIXM profile, does define a number of geometry elements that substitute for the fundamental GML types, and Any application schema can do the same thing, and the validator will work in the same manner. And of course, the suite will also verify the conformance rules in GML regarding rules for constructing GML application schemas.